Okay, I'm going to continue on continuous and discrete graphs. Okay, this is an easy thing. However, you can make it real difficult very easily. Okay, there is a difference between continuous and discrete. Okay, continuous, if we look at a graph, will continue going on and on and on and on. Okay, which means like if I put in milk, if I just put in like half of a gallon, I'm going to get some cheese, but I can change that between the things. Okay, yes, there are 1 gallon, 2 gallons, 3 gallons, but we could put in half a gallon. We could put in 1 1/4 gallon, so we could go in between. Okay, so it would be continuous. Everything works on the line. Okay, but then discrete, if you look at discrete, yeah, we have 0, 1, 2, 3, 4. Okay, this is the cost of cheese. So if I buy no cheese, I don't pay anything. If I buy 1 wheel of cheese, it's $9. 2 wheel of cheese, $18. 3 wheel of cheese, $27. 4 wheel of cheese, $36. So you'll see that it is just dots. We do not connect them. The reason being is because I can't go to the store and buy 2 1/4 thing of cheese. Okay, if I go to the cheese section, don't think about the deli or something. So you have to figure out which one is continuous, which one is discrete. So let's look at some examples. Okay, the amount of water in a wading pool in gallons depends on the amount of time in minutes the wading pool has been filling. As a related function, the rule is W equals 3T. So we have to think, is that continuous or is that discrete? Which means, am I going to stop it at exactly 1 gallon? Exactly 3 gallons? Probably not. Okay, so this would be a continuous example. Okay, all right, so the cost C for baseball tickets in dollars depends on the number of N tickets bought. As a related function, the rule is C equals 16N. Okay, so let's think about that. If I buy 5 tickets, it would be $16 a piece. Okay, so your number would change based on tickets. So if I buy 1 ticket, it's so much. If I buy 2 tickets, it's so much. If I buy 3 tickets, I can't buy 3 1/2 tickets. Okay, so that is a discrete example. Okay, so you have made a foldable and you've put it in your journal that looks like this. Okay, so on the front, a discrete function has a graph that consists of, we're just going to say points not connected. Okay, so on our graph, this would be like dot, 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 dot. Okay, continuous function has a graph that is connected. So dot, 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 but we connect the dots. Okay, all right, so let's look at some examples. We're going to look at the discrete side first. Okay, so we're just going to do like we have been doing. They've given you the x's they want you to use, which is different than what we have been. -1, 0, 1, 2, 3. All right, so our equation is 2x plus 1. So 2 times -1 is -2, minus 1 is -3. 2 times 0 is 0, minus 1 is -1. 1 times 1, or 1 times 2 is 2, minus 1 is 1. 2 times 2 is 4, minus 1 is 3. 3 times 2 is 6, minus 1 is 5. Okay, so we're going to graph it. My pen's not wanting to work. 0, -1, or wait, hold on. 0, -1. 1, 1, 2, 3, 3, 5. Okay, all right, take that back. All right, so a discrete means I would graph it and just leave the dots. Okay. And then if I identify the range, your x's are your domain, and your y's are your range. So these are my range, okay? So you can work this next example. So to think about how, why is it a discrete situation, okay? Think about movie tickets. One movie ticket's $8.50. Then 2 would be $17. I'm not going to buy 1.5 movie tickets, okay? So I want you to make an explanation. So you can explain the cost of movie tickets by each ticket you buy is $8.50. I'm not going to buy half of a ticket, okay? So why don't you think about the idea of a game of laser tag, okay? So if 0 hits, your score is 0. 1 hit is 4. 2 hits is 8. So we would think about that as each hit is 4 points. Okay, so discrete, you really look at like there's some kind of rate going on. So think about a rate. Okay, so let's move on to continuous. Continuous, notice it says the domain is greater than or equal to 0. So they're telling you they want your chart to start with 0 and be greater. 1, 2, 3. That's good. All right, so plug them in. 0 times 2 is 0, minus 1 is negative 1. 1 times 2 is 2, minus 1 is 1. 2 times 2 is 4, minus 1 is 3. 2 times 3 is 6, minus 1 is 5. Okay, if I graph it, remember this is my domain, this is my range, or this is my x, and this is my y. You're going to have tons of names for your x's and y's. So if I graph that, it's going to be 0, negative 1, 1, 1, 2, 3, and 3, 5. Okay, since it is continuous, I connect the dots. Okay, so then I want you to practice this one down here on your own. Okay, so let's look at the bottom and identify some continuous situations. Okay, so you will see that time is traveling on in hours. Okay, and the temperature is changing of this fish tank during an experiment. Okay, we cannot say that every hour the temperature is going to drop 3 degrees because we know in nature that just does not happen. Okay, so we could say it's continuous because it looks like throughout the day the temperature is dropping, but it's not constant. Okay, so a discrete is constant, continuous is not necessarily. Okay, so the temperature drops, and we can say randomly, throughout the day. Okay, so let's think about a height of a rocket after a launch. Okay, so notice at the very beginning when you launch, it's going to shoot up. Okay, so think about your graph. It shoots up, and then it just kind of goes up a little bit at a time. And then, of course, a rocket is going to have to fall back down. Okay, so just think about that and explain it. Okay, so the height increases and decreases inconsistently. So that's why we have to connect the dots to see the pattern that it goes on. Okay, all right, so here are some examples if you would like to practice for graphing. These should all be linear. Okay, here's some discrete and continuous examples. Wrong way, sorry. And then here, these should be nonlinear. Okay, all right. Feel free to. I do want you to go back in your journal on the other one, and let's graph this one on that last graph that we didn't fill in. Okay, all right, so those are some practice problems for you. And your homework is going to be in your workbook on page, let me look real quick. I don't have a book right here. So homework is in your workbook. I'm assuming it will be 123 and 124. Okay? Alright, so I will post that on the page as well. So enjoy. Have a nice day. Thank you.